Okay, we are now live. So I'm going to continue to work on my compiler. Here's the source code. I'll put it in chat. Okay. So last time we got operators. We could continuously add them instead of just having one. We also implemented multiplication and kind of division. So that's what we're going to work on today. We're going to finish division, and then hopefully you can get into integer or variables. That's what I'm gonna say. So I did just a quick thing off stream. So now we can do this as many times as we want because we were having problems with that, with the memory management and such. But now that does work. So I'll just show sort of what I did. Whoops. Alright, so if I go down here, and right here, so basically we set it to initial size, and then we keep track of the total token size and the number, and then this is the size that we multiply it by. And then if we ever get past that size, then this is just for you guys. Then we just increase it by 50%, and then we reallocate it. So this works now. Now we can continuously add that, and this probably isn't the best way to do it, but it works. So that's what matters. So yeah. So we'll do divisions. That's basically the idea that I had for it is, oh shoot, this is a little messy. Alright, so basically, here is the idea. So it'll be like this, and then basically what we'll do is move RAX and then whatever value we want, and then move RDI, whatever the other value is, and then we can just, let's see. And right, if we're adding, we can do something like this. I think that is something that works. 12. And yeah. Alright, so that is something we can do. But then if it's multiplication or division, we can just do something like that. Then if we build it again. Alright, 2. Whoops. Alright, so that didn't work. Oh yes, because we need to do actually, let's see, after we do that, then we need to move RDI, let's see, actually no, we want to use RBX instead, and then we multiply RBX, and then we move RDI, RBX. That's what we want, I think. Keep going to the wrong file. Alright, that's not, we want to move RAX actually. So now, if we build it, alright, there, so that is what we want. And then, if we're adding, we can do add RAX, RBX, and then we can do that. And I think that works for adding and subtracting as well. So let's just make sure. And generated. Next we can do this. 12. Alright, so yeah. So that is sort of the structure that we're looking at. Because then it'll all work together. So let's actually go into the code generator. And so let's see. Here's where we're handling it all. So let's see. Alright, so if it is operator, so let's see. Basically what we can do, fprintf file alright, yeah, so we want, let's see. Alright, I will modify this code and then I'll get it working with the division. So when I do this, and then we set the alright, we don't need this anymore. Value. So instead of this, we can actually do move, and then we can do fnf file, and then and we'll move rdx. Alright, actually rax. Alright, so let's see what happens now if we build this. Alright, there's an error. Oh yeah, this is already. Alright, and it does not work. So let's look at what it generated. Okay, actually, let me make it a bit simpler. Because right now we have kind of a mess, because I was testing with that. We'll just do this for now. Alright, now let's build it. Alright, and then it generates this. Alright, so I forgot to put a new line. That's part of the problem. Yes. This should be new line. Alright, and this isn't gonna work. Well, alright, yeah. Alright, so let me just... Let's try this again. Alright, let's see. It generates that. When it generates this. So now if we run it, 71. Oh, okay. So here's the problem. So I need to fix this actually. So what we're doing here is this, but instead of that, what we can do is let's do syscall number, and then here we can actually just set syscall number equal to 60, because that's what we want it to be. And then after we go through all this, we can do, then we do this. Alright, then this will also be more tileable. That's the right word. Alright, now we do need to modify the traverse tree. So we do have down here, we have this. And then the initial call of it is do what? Yeah, we'll do 0. Alright, now okay. Oh yeah, I forgot to put the move. Alright, now if we do this. Alright, so it should 11. Alright, so is that what we want? No, not quite. So let's see what the problem is. So it's adding these. Okay, so the problem, so we're moving RDI. We're just moving RDI twice, so we don't actually want to do that. So the first one should be RAX. Alright, let's see what happens now. 13. Alright, that is what we want. Let's see if it works with another number. So now it should be 23. 23, okay, and let's add a 5. So 28. Alright, 28. Alright, now it's not going to work with, well, I think it'll still work with multiplication actually. That's actually going to be a pretty big number. 138. Alright, let's see. 10, 13, 130. Alright, that's not. can do 10 times 5. 50. Okay, and then times 2. So it should be 100. Alright, so that is working. But we are going to actually modify the multiplication, because basically what we want to do here is we want to change it. So for this second one, if offer equals, if it is, let's see, shoot, alright, we can do string compare. And if it is divide, or we'll do multiply first. So then we do have to change it down here because we don't want this to be eyeball anymore. Alright, let's see. Alright, so if it is that, then we're going to do it a little bit different. Let's see. Alright, and then else we'll do this. So I think this is pretty much what I want. So what we'll do is we'll move it here, and then it's in both the registers. Then we, alright, well let's just run it and see what happens. So yeah. Alright, it did not work. Alright, yeah, let's see. Need to check that equals 0. That was the problem. Alright, and it still didn't work. Alright, we put in extra space. Alright, but that's not the problem. Let's see. Alright, the problem is we are multiplying when I do RAX. Alright, let's see. Alright, let's just work through the errors. It's frozen now. Oh, okay, I see. Let's see. So now okay, multiply RAX. But then we want to move the value into RDI. Let me get rid of this actually. We'll do move RDI RAX. I messed that up. Alright, and okay, let's see. Alright, and now if we run this 25, yeah, so that's not quite right. Alright, we actually want to move, we want to do RAX first. Yeah, so we want this to be RAX, and then we want that to be RBX. And we want to do this, yeah. No. Alright, let me see now. Alright, let's see. So move RAX, then multiply it. Alright, 50. Alright, so we do the first one now. So now we just need to fix this. So let's see. So what we would do is if it's multiplication, would move, let's see, move RAX, what's the next number? 2. And we do, let's see, move RVX. Move RVX. RAX. No. Move. Let's see. RBX, RBI, no RBX. Alright, so that is what we would have to do. So how do we do this? Let's see. So basically we just want to do the same thing again. Basically. Let's do okay. Do that. And else we want to do this. Alright. Okay. So here we want to I'm gonna run through this again. So move RAX. So yeah, we want to do that. And then into RBX, we want to move RDI. RDI. And then we want to send S RBX. Yeah. Okay. BX. And then last we want to move RDI RAX. And also this can be here. Alright, so now Alright, so operator does not exist here anymore. So we can do temp. Equals apply. Okay. All right, and let's see what happens when we run it. 100. All right, so that's good. Now multiply by 2. I think 200. 200. Okay. What if we change this to plus 2? So it should be 102. 102. All right, there we go. So now this should be pretty easy to implement divide. So if I modify this, and I think we can basically just get rid of this entirely. Mess that up actually. Alright, yes. And then we can just do this. Alright, and now let me make sure it works after doing that. Okay, so now what we can do is when we check if it's multiplier or proper is div, then we'll do that, and then as well here we'll do or value is slash. So build that. I see we have to modify this file. So we'll start with something simple. That should be 2. Alright, so let's see. Okay. Alright, so this did not work. I think we want it to... This is supposed to be RDX, so I don't know why it's RAX. Then... we don't want that. We want move RDI RAX. So that is what we wanted it to generate, I think. Yes, that's what we wanted. So, and what did it actually generate? Alright, well, so I think the problem is here. So this won't work as well with that, I think. No, let's open it. Fine. Okay. Yeah, so that is the problem. So we have broken support for that. So the problem, let's see. Okay, so we're just generating too much. So we're doing this. I don't know, why are we moving RAs twice? Okay, so we're skipping over this actually. Then we go here and we move RAX again. So I think we can actually fix that. We just place this in here. Alright, let's see now. Let's see what happens. Now, alright, still did not work. Yeah, so we're not moving the second value in if we do that. Okay, let's see. So let's move this back out here. left value. Okay. Let's generate this again. So we're moving that, and then we skip right to here. So we need Alright, so this is running through the loop, and then at the end of the loop we do this. And this works when we have more than one in here. Then it'll work. Because that's how it's structured. But we need to be able to support one as well. Probably broke it actually. Okay. Yeah. Okay. What if we do this? So yeah, that still doesn't work because the RAX needs to come first. So I can undo that I just did. So basically what we want is, once we exit this loop, we want to do one thing one way if we ran through the loop, but if we did not run through the loop. So I guess, I don't really like this, but we could do something like int did loop equals 0. And then if we go in here once, we do did loop equals 1. So we could do if did loop, then we'll do this stuff. And actually I messed that up. We'll do, hang on, yeah, we'll do this. There we go. Alright, so if did loop, else, then we'll do a very similar thing. And then we'll run that. Then we'll do that, and then let's see. Then we'll move RDI RAX. And yeah, I think that's what we need to do. Alright. Did look. Spelled it wrong. Okay, now let's see if it generated the right thing. 50. Okay. And then if we do this, it should generate 100. 100. Okay. So it's a little messy, but I think it is working now. And it should work with division. Alright, 4. So that'd be 2 times 2. Yeah. Turn this to 4, it should be 16. I mean, wait, so it's 8. Oh yeah, because that's 2, not 4. Yeah, so that's right actually. And then we should be able to divide it by 2, and that should give us 4. 0. Okay, so it doesn't work. Because that's going to be Alright, let's see what this is doing. Yes. Does it work if we put that? 16. So it's just because we're dividing in the wrong order, probably. Yeah. Okay. So I think if we just switch these, actually, something like mess that up. RDI, and then we make this 2, then it should work. Yeah, okay, so we need to switch those. So that is in here. In here. Let's see. Undo. RDI. In here we will put this. So now I think it'll work. Alright, now if we run the generator, 4. Okay, so that's what we wanted. This should still be 16. 16, okay. And if we divide it by 4, it should be 0. 2. Okay, why is it 2? 2 times 8 divided by 4. Why is it 2? The value there is 8. Wait, oh, hang on. I think I am wrong here. Yes. Because this is 8. Yes. Alright, so I was the one who was wrong. The computer was right. Alright, that's 1. That's what I actually meant. Anyway. Yes, so now you... Let's do 10 plus 5. And actually we'll do 5 plus 5 times 2. So that's going to be 20. Divided by 5. So that'll be 4 times 3. So it should be 12. 6. Alright, I probably messed something up. 10, that's 20. That's 4. I'm pretty sure I'm right. 10 times 2 times 3. 12. Okay, so why are we generating 6? Why are we generating 6? Alright, what is the value that's moving here? It's going to be 10, 20, it's going to be 4. No, it's not going to be 4. It's going to be 4. Yeah, no, it will be 4. It should be 4. We do this. 2. So why do we get 2 from that? 10 times 2. That is interesting. Oops. So why does this equal 2? So we add them. Then we move 2. Shoot. Okay. Okay. I see the problem. So after we add them, we never move the value. So this, I think the addition is what's broken actually here. So if we do something like this, I don't think it's gonna work. Whoops. 10. Yeah, alright, so the problem, I messed up the addition. So the reason, let's see. So actually, let's see, where are we doing the addition? So I actually want to do RBI, RAX, and then we want to do let's see, we want to move RDI, RBI. I think that is what we want to do. Okay, that's not what we wanted to do. RBI, it's RDI. No, it's RBX, RBX. There we go. Alright, and now we run 12. So 10. Alright, so that's closer. So we are doing that, and then we are adding them together, so that should be 10. Then we are alright, and then this time we're just adding RBX with itself. That's even farther. Okay, so let's see. Add that. Okay. Alright, so if 17 is what we want, let's see if we add 3. Okay. And then if we throw a multiplication here, let's make it a little bit easier. 12 times 3. Okay. Alright, 36, that's good. So now what if we do 5 times 5 divided by 2? 5 plus 5, I mean. So that'd be 10. That should be 5 times 3. So it should be 15. 15. Alright. That's good enough for me. So, looks as though this is working now. Let me actually zoom out a little so we can see a little bit more. So, I think we can get rid of this. And then, let's make a file for this, or a function. Okay, what are we returning here? Are we returning a... No, we're basically just modifying the file and we're modifying the node. So I think we can do this with void. Generate operator code. So we're going to take a node and syscall number. Gotta spell number right though. Then I think I just go ahead and take all this, paste it in here, and at the end, if we return node, and if we just go ahead and generate operator code, and pass node syscall number. Alright, let's see what breaks now. Okay. Oh, we need to pass the file as well. That makes sense. Yeah. File. Gotta change it up here. File. Okay. Oh yeah, we don't want to return next. Well, I think we can return. We might not have to return. We'll try with that. Alright. Build test. Alright, 15. Alright, so that's what we wanted it to return. Alright, let me do 1 plus 2 plus 3. 6, okay. And then we'll do times 2, 12. Okay, and then divided by 3, so we should get 4. 4, okay. So it seems as though it is working. And now we have generate opcode separated out, and we should be able to reuse this. Yeah. So it should work. We should be able to, when we get other operators, it should work. But we should, once we can start on variables now, and then I'll show sort of what I mean. Because equals is going to be an operator, but we don't want to handle it the same way. Okay. Let's see. So what we want to do, I will make this exit 1. Okay. Basically, we want int x equals 12. That's what we want to be able to generate. So we can get started in the Lexer. Let's see. In the Lexer, so now we need another one of these, so we can be identifier. Identifier. Okay. I want to modify the Lexer f.h as well. Add identifier. Identifier. Okay. And we gotta handle it in here as well. Case identifier. Token type identifier. And break. But actually we want to move this up here. Alright. Now let's make sure it still builds. Alright, in parser we gotta modify. Have to modify where we have this. So here we can just do case identifier. 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 And break. So we are, yeah, we're gonna be using that. So yes, now it, okay. Alright, that's identifier. What is the difference? Oops, I spelled it wrong actually in all the other ones. In identifier. That's better. Alright, now it should work. Alright, there we go. Now it should be pretty easy. We just generate keyword or identifier. Messed me up. And let's modify generate keyword. And replace that with generate keyword or identifier. Okay, and then let's see. And it should build. Okay. So now what we need to do in here is just handle. Basically what we can do is else, if it's not any of our predefined keywords, it'll be an identifier. So we can do token type equals identifier. Token value equals let's see, current. We need to generate the value. So we'll do current value. And let's see. No, actually we generated it. We can just set it equal to keyword, I think. Alright, and okay, let me modify the main.c. And we'll just do the Lexer for right now. Okay. Build. Okay. So, token type identifier. Oh yeah, let's actually handle int. So we'll do else if token keyword is int equals 0. Then token type equals keyword. Token value equals int. Okay, now, alright, so we got int, that's recognized as the keyword. X is the identifier. 12 is the int. Then we have the separator. Keyword separator int. Alright, and we should be able to basically just do this as many times as we want. So int y equals 27. Int z equals 12 again. Alright, and then it should be able to generate it all. Alright, int, throwing that keyword, z is identifier, and it should be able to be as long as we want. So Zanny, that should be Zanny. Yep, alright. So that's working now. That was pretty easy. The hard part is the parser and the code generator. So let me sort of show how we're gonna do this with assembly. So basically, right now we're just gonna handle, if I have time, we'll handle just pushing it onto the stack. So basically, what we'll do is push whatever the value is. So we'll say it's 7, right? Then what we'll do is we'll move into the register. Actually, we'll do pop. Alright, and move that into the register. So then this should be 7, I think. No, it is not. Let me see. I don't exactly remember the exact syntax. Let's see. That's the problem. Okay. So there's no comma. Now, 7. Alright, yeah. So that's basically how we're going to handle it. And we'll need to implement a stack pointer so that we know which variable is which. But for now, we'll just have one variable that's at the top of the stack, basically, right? And that's what we want to handle right now. Okay. So I'm going to take a quick break to think about it. I'll be back in like 5 minutes. Okay, so right now, first I'm gonna actually push the changes that we made. So got operators fully working besides operation order. We'll get to that later. Now working on variables. Alright, so I'll push that. Let's see. Yeah, that link's still in chat for the GitHub. So let's see. So what we're gonna need to do, we don't need the Lexer right now. In here, let's move this here. So if we build this, alright, and then we run that, then we do get, it does recognize identifier. So that's something that we want. But what we're gonna do, we should probably make like a handle exit syscall, something like that, and then we see. Well, I don't know what we need to return, but so then if we get this, we can basically just run that handle exit syscall. Basically, that's what we want to do. So let's grab this. There we go. And we'll just place it in here. Alright, so let's see, what do we need to pass? We need node root, and we need token current token. And alright, well let's pass those. Root and current token. And we'll see what else we need. Alright, case keyword. Yes, the problem is the break. This one, I think. Yeah. Alright, current undeclared. Alright, so we need to pass node current. So let's see, where is current defined? Alright, yeah, so we can pretty easily pass current as well. Okay, and let's make sure it works. Alright, and that seems to generate the exit properly. Okay. So that's pretty good. That is what we want. So, do we want that? I don't know. I don't think we need it. So now, we'll do if current token value is int, then we're going to want to do the same thing. So I think we can do handle, let's see, handle variables. Or we'll do create variables. Create variables. Current token and current. Okay. So we need to create that now. So node create variables. So I think it's a void. Void create variables. And node root. Node current token. Node current. Actually token. Current token. Yeah. Okay. So we're gonna do this in a similar way. So let's see. So now we have int. So now the next one should be equals, which actually I didn't handle the equals. Yeah, we need to actually handle that. So let's open the Lexer back up. Okay, and it's another operator. So that is, let's see. So we can add it pretty easily. I'll just put it right here. Else if current index equals, then we'll do this. Open equal generate separator or operator current index separator. And no, it's an operator. So we should actually put it with operators. So I'll move that actually, but let's just. Alright, yeah, so we want to move it down with other operators. So let me grab that. We'll put it as the first operator though. And got that. Okay. So now, alright, got some problem. Alright, that's just unused, so it should still work though. Okay. Program. See? Yep, alright, so we got the equals now. So that's something that I forgot to handle. Alright, now. Let's do sort of what we're doing here. Let's see. So we need node variable node, or we'll just do var node. Var node. So it's the var node. We'll do actually current left, and then we'll set the current equal to variable. Because sometimes it could be not. Basically, let me kind of illustrate what I mean here. So what we'll do. That's not good. Basically, we have the main program. To the right, we have the exit. And then to the left, we'll have whatever here. So we'll do something like int. And to the right of that, we have the semicolon, right? Semicolon. And to the left, we have equals. And then, let's see, actually, equals whatever value. So like 5. And then to the right, it could be something like plus. Let's see. How would we. Alright, so if it's something like 12, 5 plus 12. So equals. Then actually, what we do in that case is set this to be a plus. And then 5 and 12. Something like that. Actually, I forgot about the identifier. Int x equals. Then it can equal 5. So it could just equal 1, which goes off to the left, or it could be a plus. This is kind of branchy, but not showing very well. But you get the idea, I think. Yeah, so then we'd figure that out, equals, that's x. So that's the identifier, and that's all the total. And then to the right, this is where the next thing would go. So if we have that, and then we have int y equals 5, then what we do is branch off of here like this. Something like that, basically. That's what the goal is. So let me get rid of that, as well as this. Alright, so how are we going to do this? Alright, so what we're doing is we're setting the current node. So this is the int, the variable node. So now if it's that, if current token type equals operator, yeah, then let's see. We want it to be current token value needs to be equals. Otherwise, alright, so we'll do equals 1. Yeah, if it equals 1, then we want to printf, or we can do print error. Invalid variable syntax on equals. Something like that. And then that, yeah. So I think we can test this actually. If we go to the test file, set that, because that's not valid. Alright, we didn't actually get the error. Set the left to in. Okay, current. Let's print f current token. Current token value. X. So why are we on to X already? Alright, now, yeah, we get the invalid syntax. So I'm not sure, let's see. Okay. So why does he go straight from int to X? Oh, shoot. Okay. We have to handle the identifier. It was right. I just did a stupid identifier. Okay, so that is the problem. So what we want to do, so next, if token type equals identifier, which we already checked if it is, but we'll just check again. Then let's see what we want to generate the node. So current, well, let's look at our illustration. So we want the left to equal current node. Let's actually node identifier node, and let's see, identifier node equals init node. Okay. Yeah, and then let's do current left equals identifier, because then we're setting that. Okay. We can do current token. We can set current equal to identifier. But then after we run through this, we want to set current equal to variable node. at the end, because then we're going to set if current token type equals separator. And current, and we'll do current token value is semicolon. Then we'll set current, well, current.write equals, yeah, it's actually copied it. Okay, current.write equals seminode. Okay, and let's see, what do we actually do at the end here? Yeah, alright, current. Okay, so now the next one is actually going to be an operator. Current token type equals end of tokens. Then we'll print error invalid syntax after identifier. Okay. Yeah. So now we know that it exists. So it has got to be this. So actually, let's check or current token type is not equal operator. Okay. So now we're sure it is. So if it's an operator, so let's actually test this now. Alright, we have some problems. I spelled current Takumi. Okay. Name. Okay, what is in here? X plus Y. So let's see. So why is it not? Let's see. Let's print f current token and then current token value. Alright, and let's see. Plus. So why don't we get an error? Current token type equals end of tokens, or it is not an operator. Equals operator. No, plus is an operator. Okay. Alright, yeah. So that's what we want to do. Alright, we noted that. And now, so let's see. So now we want to create the equals. So that's going to be to the left again. So it's node equals node equals node init node token value and operator. Current left equals node. Current equals node and current token plus plus. Okay, So now it should generate. Alright, so now it's starting to take shape. So we have the integer. Yeah. Alright, we'll get to that. So we have the integer and then the equals. So now we'll do, let's see. So we'll sort of do this again. I feel like, yeah, we can separate this out into void, handle. Let's see. I already have the print errors, so maybe I could just modify that. Well, no, because that's going to be a different thing. So void handle token errors, and we will take error text and token type. Then we'll do if current. Yeah, we need current token as well. Type equals end of tokens or current token type is not equal type. Then we'll print error text. So then we should be able to just handle token errors. Invalid syntax after int. Current token and identifier. Alright, so now that's going to check, make sure it is an identifier after. So it should all work like that. But if we change this to be an equals, then yes, invalid syntax after int. Okay. So now this is going to make it a lot cleaner actually. Handle token errors. Invalid syntax after identifier. And token operate. Okay. Alright, so that's a lot better now. And let's see. So I'm going to do the exact same thing here. Handle token errors. Invalid syntax after equals. Current token, and so we want int. So that's what we are expecting. Okay. Alright, and if this is another identifier, it's not going to work. Alright. So we'll be able to handle that, like assigning variables to other variable values, but we're just doing the int at the moment. We'll add the basic functionality and build off of that, basically. Okay, so now we know that it is an int. So node size of node. Okay. And node current token value and int. And then let's see. So the current is now the equal. So current left equals expert node. Current token plus. So now, right, that should generate the whole tree that we need. Let's see. Current token. There we go. Alright. So that should generate the tree properly. Alright, yeah. So we can get started on this, and then we'll add like the ability to have actual expressions in the, so something like this plus 5 or whatever. But we're not worried about that now. Yeah, so that is what we want. So it didn't set the semicolon. Okay. Value. All right, let's see. Core rent token is semicolon. So why does it not set? Should set the right to that. Let's see. All right, how do we handle this up here? All right, yeah. So current node is so it should be let's see, actually what we want to do is handle token errors, invalid syntax after expression, current token separator. Current equals okay, I think what we can do, if we take this and we just add it directly onto here. There, no. Then down here we can just, oh, you know what the problem is? I know what it is. We can just get rid of this entirely. Okay. Problem is that. There we go. Now it'll work. Yes. Yep. I always forget that. Alright, now we can get rid of some of this stuff. Okay. So now we are generating the tree. Very left heavy, but that's okay. So let's see what it tries to generate. It's obviously not going to be right, but it's going to error. Segmentation fault. Alright, because we're not handling it. So let's see. Let's see. So if node type, node value, node type equals int, then received int. All right, and oh, I think yeah. All right, actually, let me move this. I'm gonna do if node value int, then we'll do receive int. All right, and that. All right, so it still does that. Received int. All right, so we recognize that. So what do we want to generate? If we get to int, let's see. So what would it look like in our code? What are we? Let me see. So we can do global text. Nope, that's not right. Section text global start, and we'll move 60, move RDI 1, and 6. Alright, and I think that works. Okay. So we want to push whatever the value is, and we'll just push it. So if it's 8. And then what we want to do is pop RDI. Right? So if whenever we retrieve the value, we want to pop it. Yeah, okay, so that's what we want to do. So if it is int, then we're creating a new one. So then it's going to be push. So push. And then if we, let's see. So I don't know that we have to generate anything here. But then if we get here, so if we generate operator code, let's do if node value is equals, then we'll equals, else we'll do all this stuff. Okay. Alright, and it still does that. Equals 0. Gotta do that. Okay, equals. So what did we? Alright, yeah, so obviously they didn't generate it correctly. So basically what we want to do is navigate through. So the left is going to equal, yeah, basically we can just f and f file node left value push that. Oh, and also we want to set node left equals null. Okay, then if we go in here, push 5. but then we are calling syscall again, so we don't want to call that actually every time. What we want to do is syscall. So we only want to call it when we need to. So probably won't even be like that, but we can just leave that empty. Okay, so now push 5. All right. Let's see. So why is it not generating the whole thing? So we push the 5. That's what we wanted. All right. Let's see. Pushing 5, but then we're not doing the exit code. So the tree generated looks like this. So set. Oh, okay. So then I think we need to, Alright, so we are still calling this with the 1. Ooh, okay. So here it, alright, I think this would work with an expression. Alright, did not work. Got closer though. So I don't, why did this not work? Valid op combination. Do that. Alright, what doesn't work here? RBX. So why doesn't that work? Why does it not work? Let's see. So the add is still broken. Thought I tested it, but alright, then it works with that. Okay. So that is a problem. So if we just have a single integer, it doesn't work properly. Alright, I think what we can do actually is Alright, so that is working now. And we are pushing the 5. So that's what we wanted to do. So now when we access it, alright, we want to be able to do this. So I'll fix the plus later. I'll probably do that off stream. So this is gonna just be very confused. Yes. Okay, invalid syntax. That's a weird place. Let's see. Oh yeah, that's where it breaks. So yeah, we need to actually modify this. So it could be int or an identifier. Alright, let's see. For token type equals identifier. Alright, what does this do now? Okay. Yes. So this, instead of, so when we come across an identifier, we don't want to do that. So let's see. If node type equals identifier, then let's see. There we go. So we want to do, basically right now what we want to do is just pop. That should be pop already on. Okay. Why does it do it so many times? Let's see. Okay, so when we're parsing it, oh yeah, we're still setting it to int. So that is the problem. Let's see. Let's see. Okay, now, why are we moving 0? Okay. So we come across the identifier twice. Okay, and that generates a whole bunch of stuff. So we don't want all of this. So we can't pop for push anyway. So whenever we come across the identifier, this is what we're doing. We only want to do this if the previous node. Let's see. If the previous node up here is in, well, actually, I guess we could do if node left. Let's see. Node left value is equals. Then we will not do this. Else we will do this. Alright. Let's see what that does now. Okay. So why are we still generating that? Oh shoot, actually I messed this up. Put this in the wrong place. We want to do that right down here. So if node left value is equals 0, and we want to do string comparison. Okay, then do that, else. Actually, probably a better way to do this would just be this. We can get rid of this. Okay. Alright, now it broke. Okay. Let's see. X equals, we got to equals, and we got to the next identifier. Alright, let's see why this is happening. So we get to the equals. And it breaks on the integer. Okay, let's see. So we don't want to do this if, well, but we skip over that here. No. Okay, so we don't actually make it there. So we do that, so identifier, and then it breaks on the operator. Okay, yeah, so it is right after that when it breaks. Yeah, alright. Let's see. All right. Int x equals 5. My terminal is broken. Let's just start it. Then code generator. .c. All right, and let's see. So build.sh build/name test. Okay. All right. Test and add something. I need a symbol. Okay. So all right. Oh, okay. So let's see. If node dot let is not equal null, or node let does not equal end of no, just null. Then we can do this. Okay. There we go. All right, now let's see what it generates. Push 5. Let me exit with 5. So now this push 5, and then we want to exit pop. Okay. So what is the node? Switch these around. All right. All right. Let's see. What do we actually have here? So yeah. So there's no left that. Okay. What if we just do type identifier? Alright, then it doesn't work still. Okay. Alright, let's see. So let me just set this back up. Open parentheses, semicolon, and let's see, what is left of that is x, right is closed, yeah, that's an x, and let's see, right is closed, and that is it for this. So x, alright, that doesn't really look like an x, but that's alright. So what we want to do, okay. So what is that here? Next to null. No, this doesn't go here. Right, yeah, okay, it goes down here. There we go. Okay. Next to null is x. So this is what we are on, where we have the problem. Okay. So now I think it did generate the proper thing. 5, yes. And we can change this. We can set this equal to 7, and it will print 7. Yes. Alright, but the problem is we are very limited now on what we can do. And I don't know if this still, it should still work. No, it does not work. That'll work though. Yeah. Alright, so the plus is broken. So I need to fix that. Why is it broken? Is it broken if we leave it at that? Yes, it's still broken. Okay. And now we can do this, and let's see what this does actually. Five. All right. Yeah. Okay. That's kind of weird though. Oh yeah, because we're just overwriting it each time. So what we actually want to do is start from the center. So actually, let me open up the parser, and I think what we can do is just right here, we do current equals semi-node. Let's see what that does. Alright, and then, alright, that still doesn't work. Yeah, and then if we come down here, we can set current equal to that. Okay, and then I think that would generate a structure something like this. So left in left is x, and left is equals 5. And then to the right of this is the semicolon. And that is where we, yeah. So then it's basically just building a tree down here. So it, like if I go here, I can do int z equals 10, int that equals 11, int foo equals 12. Something like that, and it'll generate this very big tree. And we get a bunch of errors, but yeah, it does generate the big tree. Yes. And then the most recent one that we set is what gets set out. So alls equals 15, and then 15 will be exit coded. Because basically we're just pushing it to the top each time. But, so basically, we have a lot of stuff that we have to do. And we can't do something like +5, because that just breaks the whole thing. Because we don't support that at all. Yeah, so that's something that we need to handle. So I can't do it today, because I'm out of time. But basically, we need to handle that. And what I was thinking, right, so we have the stack. I can illustrate it. We have the stack, can't draw very well, right, and we push things onto here, right? So we have like 7, 8, and 9 when we push it on there. So like this could be X, this could be Y, and this could be Z. And basically what we want is a pointer that can point to each one, and we'll use the hash table, which we used before, hash, and then if we give it the value of x, and then that will equal whatever the index it is at, right? So then we can move the stack pointer to the index that it's at. So say we look at the hash table and we want to find y, right? Then it will move this pointer to where y is at, because that equals 1. and then we'll take this value and we'll push it onto the stack again. So 8, and then we'll pop it. So whenever we try to get the value of y, we are going to basically move through that kind of thing by looking at the hash table, whatever the value is for the pointer. And I think we can do it like that. So then, yeah, we push the value, push this value to the top, and then pop it. And then that is whatever we want whenever we try to access it. So here, x would be set at 0, right? So then we look at the stack, x is at 0, and it's equal to 7. So we push it to the top, and then pop it, and then we have the value of it. So that's how that's going to work. And yeah. So that's what I'll work on. Some of it off stream, just kind of clean things up, make it a bit nicer, and then next time we'll work on that. So yeah, thanks for watching. See you next time. Bye.